Hey, hello, welcome back. This is number 4 in the Helm mini-course series for YouTube. If you've been following the first 3 parts, we've really just been testing Helm. We used MySQL as a sort of a quick exercise just to see how Helm works. But from now on, we're going to do some more significant work that is more like the kind of work you're going to be doing on production projects. Now, as I've been mentioning, this is an extract from a full 30-hour course on Kubernetes, where we start from zero and work all the way up to a full production cluster running in the cloud. It's a pretty deep course, but I reckon is accessible really to anybody with an interest in computing or DevOps. But you don't need to do that course just to get value from these videos on YouTube. But I'm going to make a few references in this video to that training course. Now, one big thing we do on that training course is we install a full monitoring stack onto our cluster. It's a tool called Prometheus together with Grafana. And we use that to just check that the cluster is running properly, there aren't any servers catching fire, and basically it checks that everything's running smoothly. And if it isn't, it will do things like send text messages to a system administrator. So it's a really useful stack, but it's quite complicated to install. And I'm going to show you in this video how you can install it pretty easily using Helm. So link in the description below, but if you're here for Helm, then let's have a look at how we would install a monitoring stack. It's time now to explore Helm in a bit more detail. And to do that, we'll use a chart that you're more likely to be using on a production cluster. Earlier in this course, I gave you some YAML, which gave you a full monitoring system. We had charts provided by Grafana, we had metrics gathering provided by Prometheus, and we also got an alert manager. And that was thousands of lines of YAML. Where did I get that YAML from? Well, of course, it came from a Helm chart. So in this video, we're going to find out what the source of that Helm chart was. We're going to play around with that one, and we're going to see how we can customize that Helm chart. The end result of this series of videos is I'm going to be showing you how you can regenerate that raw YAML file for yourself so that you can install the monitoring without even having Helm present on your cluster. So imagine you're on a project and you've been given the job of installing monitoring into the cluster. On this course, I want to explain how you work things out rather than just telling you things. Now, I'm working on the assumption that you already know at this point. A common solution for monitoring a Kubernetes cluster is to use Prometheus to gather the data from your nodes. And I assume you also know by now that you need some kind of front end onto Prometheus. Very commonly used is Grafana, which will give you nice graphical charts to visualize the data. And you also commonly need an alert manager as well. Really, the Artifact Hub isn't a rich enough search engine to tell you that. You couldn't have come onto Artifact Hub. Your boss has just said you've got to install monitoring onto the cluster. If you were to try typing monitoring into here, as I say, the engine isn't sophisticated enough to tell you, oh, the most common way of monitoring is to use Prometheus. What we've got here are just some unrelated, I don't even know what these things are. So that's not a criticism of the Artifact Hub. I'm just making the point here that you would need some prior knowledge. So you'd be doing some background research. Obviously, you could use a good training course like this one. So one way or another, you'll work out that, right, what we need is Prometheus, Grafana, and an alert manager at the very least. So certainly you could come into the Artifact Hub and search for Prometheus. And you've got to spell it right, of course, and we're getting there the usual kind of results. Now, I won't go on any more about this rather unsatisfactory situation that we're getting lots and lots and lots of results for Prometheus. Again, that's because there are just lots of different communities who are deciding to host Prometheus. It's open source, so they can do that. One of them is indeed Bitnami that we visited previously. So you might think that's a good one to go for, but Actually, again, I'm using previous knowledge here. We know that Prometheus on its own is not enough. We also want Grafana and an alert manager. If you've done the previous section on monitoring, you'll know that there is a common solution where we can install all three at once. And it happens to come from the Prometheus community. I don't know why it's not showing up on this search results, but if I follow the link through to Prometheus community, if we follow that link through, actually their most popular, at the time of recording at least, their most popular chart that they're hosting is the Kube Prometheus stack. And as described here, this collects together the Grafana dashboards and some pre-written rules. That's something I keep forgetting. If you just went for raw Prometheus, you would have to define all of the rules for what designates a node that's running out of CPU and that kind of thing. Well, with the Prometheus stack, you get everything predefined. And you really don't need to do much tweaking or tuning of this to work on any production cluster. So this is definitely the chart that I recommend for monitoring. Well, how do we install it? Well, you know how to do that now, but going a little further down, it's the same steps we followed for MySQL. We need to add the repository because we haven't yet added the Prometheus community repository. One thing I didn't mention previously is you should also do a Helm repo update, which just refreshes the state of your local client with the state of the remote repository. And then finally, we do an install in the same way that we did before. So let's have a go at installing Prometheus. Now, earlier in the course, we only installed Prometheus onto a production cluster with multiple nodes on AWS. And the reason we did that actually is because the Prometheus stack is very resource intensive, and there just wouldn't have been room to have Prometheus on Minikube alongside the application with the 4 gigabytes of RAM that we've been using as standard on this course. But because we don't need an application now, we can just install the monitoring solution. It will actually just about fit into 4 gigabytes. I think it might even fit into 3 gigabytes. So if you're following along, I recommend you start with a fresh Minikube. So we'll do a Minikube delete and then restart Minikube. As I say, 4 gigabytes of RAM should be enough for this demo. Okay, so the tedious job, first of all, of adding the repository. I'm going to vary from the user guide here. I'm going to do a Helm repo add, but I just want to remind you that this first parameter here is just a label that we want to use locally to refer to this repository. Now, I can never spell Prometheus, so I'm going to change this label to prom-repo, really just to prove that that is a label and we can use anything we like there. We do, of course, need the correct URL here, https prometheus-community.github.io/helm-charts. Once we've added that repo, we'll just confirm that with a Helm repo list. And we can see now that prom repo is alongside our Bitnami and the useless stable repository. Okay, and as mentioned here, we should also do a Helm repo update. It's good practice to do that whenever you add a new repository. Okay, so we're up to date, and exactly as previously, when we do a Helm install, we have 2 parameters. The first parameter is what do we want to call this installation, and we're going to find that useful whenever we're doing any management of this installation, such as upgrading it or in the future uninstalling it. We can use anything we like there, and we're going to use the string monitoring. And the second parameter is the label that we just defined. For us, that will be prom-repo / and then the name of the chart that we're going to download. And of course, we can't change that. So for us, it will be a Helm install. We're going to call this installation monitoring, and then the repo name, prom-repo / and the chart is called Kube-Prometheus-stack. If we've got all our syntax correct, we should see some action here. Now, the first thing to point out is don't panic about this. This is just a warning we're getting here. What we're seeing here is that the underlying YAML that is being applied to our cluster has a bit of YAML in it that has now been deprecated in the later versions of Kubernetes. And they're just warning here that if you're on Kubernetes 1.25 onwards, then this chart's not going to work anymore. Now, just checking, if I do a kubectl version, I'm recording this on Kubernetes 1.21, so there is actually a while to go before this chart will not be working. And I have to assume, let's hope so, that the Prometheus community will have updated the chart by the time this becomes a problem. So you may or may not see this warning. It is just a warning, and it should have gone away by the time it becomes a problem. But apart from that, you should get a message saying that the status of this chart is now deployed. What can we do to verify that? Well, if we do a Helm list, that's just Helm list on its own, this will give us a list of all of the charts that have been installed. So that's giving me the version of the chart that's been installed, which is going to be useful for configuration management. It's also giving me a revision. Now, as we start to play around with this installation, that revision will go up by 1. So we'll see that in action later. But really, the action is if I do a kubectl get PO, we should see that we have a whole set of pods that for me are now running. Now, be patient here. It will take a while for all of these to download. I've been rehearsing off camera, so actually I already had these images downloaded, so they've started up pretty quickly for me. It might take a while for your pods to get up and running. At first glance, it was as easy as that. We have installed a full monitoring system into our cluster. Now, I very much doubt that the whatever defaults we've got with this chart are going to be suitable for us. We're going to want to tune something. So I think we'll look at how to change the configuration in the next video. But for now, I'd just like to confirm that this chart is actually up and running. If we do a kubectl get svc, we have a lot of services that have been installed with this. If you've followed the section on monitoring on this course, you'll know already what all of these things are for. Just in case you haven't, then monitoring Grafana, and I'll copy that label, is actually the front end. That's the service that we want to access. Now, we need to work out a way of making this easily accessible. And in fact, that's going to be one of the major tunings that we make to this default installation. But for now, just as a very quick and dirty way of getting into this service, I think we've done this many times on the course so far. Not something you do in production, but it is useful when you're just trying things out. I'm going to do a kubectl edit on that service. And it's the monitoring-Grafana service. This will pop up whatever your default text editor is. And my plan is, if we scroll down to the bottom, we can change the type from cluster IP to node port. And be careful to get capital N and capital P here. And we can also plug in here on the list of, under the ports property, we can add in, and I'm going to put this directly under target port, I can set a node port of any of those 30,000s. And I'm just going to go for the first one here, which is 30,001, 30001. As I say, I think we've done this many times on the course so far, but just in case you've come straight to this section, I'll just point out that if you make any kind of error here, for example, if I didn't get the case correct here, so I'll put in a lowercase n here on the type. If I then do a save and exit this editor, it's telling me on the console that there was an error and that file was invalid. And it started up the editor again. Now, it's not that clear if you're not used to this, but it's put here in the comments at the top what the error was. So it's saying that we have an unsupported value for the spec type. This node port that I wrote is not valid. The supported values are one of these 4, and it's that one that we wanted. So I have to mention that every time I do this because it's a very common problem that you can't get out of this editor and you think something's gone horribly wrong. It hasn't really. We just need to put in a capital N there. But remember, this one here is a lowercase n. Hope that makes sense. This time around, if I save and exit, I've got control back on the command line. So if I go back to the kubectl get svc, we now have the situation where we have monitoring Grafana is a node port, and we can access it through port 30,001. So the usual routine, you should know this by now. Whatever IP you're using to access your cluster, your minikube, or whatever, :30,001 should be bringing up the Welcome to Grafana page. We're up and running. The first big question is, what is the username and password going to be? We never configured that. I think this is a good place to stop, so I'll answer that question in the next video when we'll start to tune and configure our Prometheus stack.